Yeah, ngā mihi nui, great to be here, Nelson. You always turn out in such big numbers. It's just great. So, yeah, James and I aren't here to really bore you with scientific detail and graphs, although I am going to show you a couple more graphs. We're here just to remind you why the problem's urgent. And really the conversation is not so much about the science, it's about how we tell our story better. And the way that story Nick gave is just incredible, the way she's using her art and with communities to reaffirm that relationship that we are, have this partnership with the planet. So I'm going to talk a little bit more about where James was heading and just talk about some of the impacts and issues that we're going to experience in New Zealand, particularly sea level rise, and focus a little bit on Nelson, just so you realise why it is so important that we do try and reach that Paris target of 2 degrees, and how we need to change the hearts and minds, as Sarah said. So, there's a graph. Sea level rise. James mentioned it. We've had not much sea level rise for the last few thousand years, and then come the Industrial Revolution, surprise, surprise, after putting all that CO2 into the atmosphere and heat into the ocean, we've had 20 centimetres of sea level rise. And you can see there's an acceleration in that as you get into the later 20th century and into the 21st century. So it's rising and it's getting faster and faster. So that's a global average. It's the global average of all the tide gauges, but now we have satellites which give us very precise detail of how the sea level is changing. And what we see when we look at that satellite information is it's not changing at the same rate everywhere. Those red areas are where it's rising much, much faster. The global average is about 3 millimetres per year, but in some places it's been rising at 3 or 4 times that. And you note that the hotspot sort of in the western equatorial Pacific, where a lot of population exists, some of it quite poor, some of it very low lying. And I guess what this points out is one of the injustices of climate change is those that didn't really contribute to it are getting affected most by it. And then the other thing that people often look at that plot and they go, ooh, there's a big population in those areas, and New Zealand and Australia aren't very far away. So, we thought 2 million Syrian refugees caused a bit of trouble in Europe. 150 million people live within 1 metre of present-day sea level, and a large majority of them in that area. So sea level isn't rising equally everywhere, and it's quite important to understand why and where it is rising. So what's causing sea level rise? Well, as James said, 93% of the heat we've produced from putting the greenhouse gases in the atmosphere has actually gone into the ocean. So to a certain extent, the ocean is our friend. It's slowing the pace of the warming. As James said, we'd probably be 50 degrees or more warmer had we not had the ocean. But one of the consequences of heating up water is it expands. So about a third of the sea level rise we've had so far has come from the heating of the ocean. Another third of the sea level rise we've had so far has come from the melting of the polar ice sheets from Greenland and Antarctica. And another third has come from the glaciers such as the Southern Alps glaciers, the Peruvian glaciers, the lower latitude glaciers. Now the glaciers don't have much more to give. They'll largely be gone by the end of the century, as we pointed out with the Franz Josef Glacier, but they can give us about another 0.5 metre of sea level rise. But the elephant in the room, of course, is the polar ice sheets, and particularly the Antarctic ice sheet. There's many metres of potential sea level rise locked up in those ice sheets, and one of the biggest questions that scientists are grappling with in terms of understanding what a warm world will look like is how much and how fast will sea level rise, and that very much depends on how fast those polar ice sheets melt. And I'll talk a bit about what we're learning about that, and we're learning the science is moving very, very fast in this area. So in 2013, the Intergovernmental Panel on Climate Change put out this report. It does it every 6 or 7 years. James and I were a lead author on that book. James is a sucker for punishment, so he's having another crack at it. And there's a few of our colleagues at Victoria are involved. Now, that is a sea level curve, historical, going back to 1700, and up until the present day. I don't know if is there a pointer there? There is. So this is that 20 centimetres I showed you in the 20th and 21st century. And then, of course, the aim of this report is to say, well, what does the future look like? What do the models, with the best information we have, tell us about where we're going to be by the end of the century, by 2100? Now, James showed you this temperature scenario. He said if we stay below 2 degrees, that would be in line with the Paris Agreement. And so that's a hopeful future. That's a future in which we aggressively reduce our greenhouse gas emissions, and we have to get onto that pretty quick. So as James pointed out, 15 to 20 years at the current rate of emission, we're going to be at 2 degrees. If we want to stay under 2 degrees, we have to peak our emissions now and pretty much reduce carbon dioxide emissions to zero before the end of the century. And that's, of course, the policy our Green and Labour-led government are trying to bring into effect. Okay, so what does it mean for sea level? It means if we achieve the Paris target, we're still going to get 50 centimetres of sea level rise. We can't avoid that. That's locked into the system largely because of the heat that's in the ocean. Once it's there for a very long time. You might be able to cut the surface warming, but the ocean takes a long time to cool down. If we do nothing, we end up on this track, and in 2013, we thought the worst case scenario looked something like 1 metre of sea level rise by the end of the century. However, there's a little bit of a problem there, and that is that we didn't really add the Antarctic ice sheet in, because we sat around, looked at each other, scratching our heads, going, we don't know what the Antarctic ice sheet's going to do. And so the wisdom was to leave it out. Because, decision makers don't like uncertainty. We could have put a big uncertainty on there, but instead we left it out, which I think creates more uncertainty. But anyway, we just didn't know enough. And we did know that it is capable of doing quite dramatic things, behaving in a very quick and abrupt way. We know that from the paleoclimate records from the past, and some of the models were starting to show that. And a lot of work has gone in with into the science, and I'm going to show you what our latest estimates are for the Antarctic ice sheet. I'm going to add them on to that graph we were just looking at. So ignore the thermometer for now, we'll get to that. So there's where we were in 2013 with the IPCC report. We now realise that because of all that heat in the ocean, a lot of it's gone into the Southern Ocean actually, about 80% of it's gone into the Southern Ocean. And well, the number varies between 60 and 80%, sort of quite hard to measure the heat in the ocean. And it's starting to get up around the edges of the Antarctic ice sheet. So much of the Antarctic ice sheet sits below sea level, and it flows into the ocean. So if you warm the edge of it and you get warm water into its underbelly, it can go really, really quick. So the physics, these processes are now being built in to computer models that make these projections for the future. And I'll show you a couple of examples. So this is a project that came largely out of the Victoria group, a paper that was published in Nature, and our estimate was that for business as usual you can add another 40 centimetres, right? But we didn't have all the bells and whistles in our model. This is our colleague in the US, and they're saying you can add another metre for the worst case scenario. So this has really thrown the cat amongst the pigeons, so to speak. It really is a head scratcher for planners, for decision makers. If you're thinking about infrastructure that's going to be around 100 years, what do you plan for? Are these crazy scientists really right? Now, I don't know what the exact number is. This is very early days, but it's certainly going to be higher than we said in 2013. And it'll be up to James and our colleagues to assess the latest science and come up with a better set of predictions for the future. Okay. So we can still achieve the Paris target, but it's tough. If you add up all the pledges that were put on the table at Paris from all the nations, and we deliver on them, we're about 2.7 degrees of global warming plus or minus the error. But if you look at what we're actually doing, current policy settings, we're nearer 4 degrees, we're 3.5 degrees of global warming. So that's the challenge. And I'm making it sound hard, and it is hard, but it's actually doable. And New Zealand may be an example, if we really can pull this off and make transition to a low carbon economy, an example of how this can be done. So that's the role of policy. Do we have this future way up here, or do we have this future down there? And unfortunately with the Antarctic ice sheet, it looks like there's a bit of a tipping point. I won't have time to go into all the details, but it's to do with the heat of the ocean, and it looks like if you get the world above 2 degrees on average, that's enough heat in the ocean to lose the ice shelves around Antarctica. If you lose the floating ice shelves, then the ice sheet flows much faster under gravity into the ocean. So you don't just get a little bit more sea level rise, you get a lot more sea level rise. So one of the things we're learning is that perhaps the Paris target is the threshold. We stay below it, we save the Antarctic ice sheet, we go above it, we don't just get a few centimetres of sea level rise. Actually, some of the models say we get 15 metres of sea level rise just in 500 years. So let's just see what that means for us. This is an example from Nelson, from a report done by the Cawthron Institute, a few years back now, I must say. And, you know, it's this raising the bathtub level and seeing what it looks like. And I can't exactly remember the numbers, but I should, and I apologise for it, but I'm pretty sure the yellow is 2 metres of sea level rise, and the red is about 1.5 metres of sea level rise. So these sort of scenarios could come into play if the Antarctic ice sheet does respond the way we think it's capable of this century. So there's some numbers up there, as James said. Doesn't matter what we do, we've got a plan for about 30 centimetres of sea level rise. That's built in, but then the futures diverge, and that's dependent on policy and how much we reduce our CO2. And so if we don't get on top of this problem, then, you know, we're looking at anything from 70 to 200 centimetres to 2 metres around the New Zealand coastline. And, you know, there are various reports out from the Parliamentary Commissioner for the Environment that just show the assets, the houses, the risk of that sea level rise, at what's at stake. So I'm pretty much going to leave it there. I just want to say we're onto this in New Zealand. We've got a big new program to better predict sea level rise for locations such as Nelson. And one of the things that we have to deal with in New Zealand is that we have a land that's going up and down, as well as the global sea level going up and down. And places like Wellington, the lower North Island, is going down at about 4 millimetres per year, and the sea level's coming up at 3 millimetres per year. So that's almost doubling the effective sea level rise. So it's very different for different parts of the country. Northland's very stable. I think there's a bit of subsidence around Nelson, but we're working with GNS scientists who have all the latest vertical land movement information to build that in, and we're improving the ice sheet models, and it's a very big collaborative program with regional councils and local authorities to just get better predictions for planning for the future. So there's a little bit of advertising to show you what's going on. Hopefully also the message is that to be forewarned is to be forearmed. The science tells us what's happening. We can prepare for it, even if we don't get on top of the CO2 emissions. So I think I've well and truly outspent my time, and I'll finish there. Thank you very much.